Assalamualaikum warahmatullahi wabarakatuh and good day again class. So continuation pa rin ito ng discussion natin sa lesson 9 and analytic geometry in 3 dimensions. So in this module class, we are going to discuss the equations of lines and planes in space or in R cube, distance from a point to a plane, and lastly the spheres or the cylinders. So here we have the equations of lines and parallels in space. In plane analytic geometry, a single equation of the first degree, ax plus by plus c equals to 0, is the equation of a line, so long as a and b are not both 0. In geometry of 3 dimensions naman, such an equation represents a plane. Kung etong equation na to class, sa 2 dimension, this is an equation of a line, pero sa 3 dimension class in geometry, etong equation na to represents a plane. Although we shall postpone a systematic study of planes until later in this section, we assert now that in 3-dimensional geometry, it is not possible to represent a line by a single first-degree equation. A line in space is determined by 2 points. If point P sub O and point P sub 1 are given points, we seek an analytic method of representing the line L determined by these points. The result is obtained by solving a geometric problem. A point P different from point P sub O. Take note of that is on L if and only if the direction numbers determined by P and P sub O are proportional to those determined by P sub 1 and P sub O. So in this figure, ito yung point P natin. This is the point P sub 1 and then point P sub O. Magkaiba si point P at saka si point P sub O. Calling the proportionality constant P, we see that the conditions are x minus x sub O equals P times x sub 1 minus x sub O, and y minus y sub O equals to P times y sub 1 minus y sub O, and lastly the z minus z sub O equals to P times z sub 1 minus z sub O. Thus, we obtain the following theorem. The two-point form of the parametric equations of a line. Okay? Meron din tayong two-point form of the parametric equation of a line sa 3 dimension. Meron din doon sa 2 dimension. Okay, so sa 3 dimension class, we have x equals to x sub O plus x sub 1 minus x sub O times t. Pag may variable t na dito, ibig sabihin parametric equation yan. And then the other one is y equals to y sub O plus y sub 1 minus y sub O times 3. And lastly, z equals to z sub O plus z sub 1 minus z sub O times t. So these are the two-point form of the parametric equations of a line. Given 2 points P sub O and P sub 1, the point which is P of the way from P sub O to P sub 1 is the point P, whose coordinates are given by equations above. Okay, so ito yung sinasabi niya, equations rather. For example, find the parametric equations of the line through the points A. Parametric equations, okay, ito yung gagamitin natin ng formulas, of the line through the points A, 3, 2, and negative 1, and the point B, 4, 4, and 6. Locate 3 additional points on the line. So substituting in the equation above, in theorem 9.13, we obtain x is equal to x sub O plus x sub 1 minus x sub O times t. So we have x equals, okay, ang 3 na yan class, yan yung x sub 1 natin, okay, x sub O rather, we let the point A as point P sub O. So x sub O is equal to 3, y sub O is equal to 2, and z sub O is equal to negative 1. Tapos, si x sub 1, y sub 1, z sub 1 natin is yung point B. Okay. Si x sub O, replace it by 3, galing dito sa point ni A, and then sa coordinates ni point A, and then si x sub 1 naman, galing siya dito kay B, that is 4, and then minus x sub O, so ang x sub O natin is 3, and then si variable na t. So 3 plus 4 minus 3 times t is, we have x equals to 3 plus t. Okay, another, y equals to y sub O. Ang y sub O natin is si 2, galing kay A. And then, y sub 1 natin is si 4, minus 4 na si y sub O. So, 2 rather. So, 2 plus 4 minus 2 times t is y equals to 2 plus 2t. Okay. The last parametric equation is z equals to z sub O. So, ang z sub O natin is negative 1 plus z sub 1 natin is 6. Okay. Minus negative 1. So, that's why naging z equals to negative 1 plus 6 minus the negative 1 times t is equal to z equals negative 1 plus 7t. So, ito yung mga parametric equations of the line through the points A and B. To get an additional point on the line, we let t equals to 2 and obtain p sub 1, 5, 6, 13. Kung t equals to negative 1 naman, yields point p sub 2. Ito yung mga obtain natin. And t equals to 3 gives p sub 3. So, nag-let lang tayo to get an additional point class. Pwede tayong mag-let ng value ng t para maka-obtain tayo ng additional point class. Okay, so, substitute lang natin dito kung t is equal to 2. Kung t is equal to 2, we have x is equal to 3 plus 2 is 5. Okay, so ito siya. Kung dito naman sa y, 2 plus 2 times 2 is 2 plus 4, 6, diba? And then kung t is 2 rather, magiging z is equal to negative 1 plus 7 times 2 is 14 minus 1, 13. Kung ang t natin is 2, if we let t equals to negative 1, substitute natin dito class sa parametric equation na na-obtain natin, ang makukuha natin na points is 2, 0, and negative 8. Bakit? When t is negative 1 here, magiging x equals to 3 plus the negative 1 is 2, diba? Sa y naman is y equals to 2 plus 2 times negative 1. So 2 minus 2 is 0. That's why 0. Sa z is negative 1 plus 7 times negative 1, that is negative 8. So, kung tinanong kung ang sabi sa given na example is locate your additional points, pwede kayong mag-let ng value ng t and then substitute nyo lang doon sa parametric equation na na-obtain ninyo using the theorem 9.13. Okay, so pwede din na t is equal to negative 2, t is equal to negative 3, depende na sa inyo. Pwede din na t equals to 0. Okay, it's up to you. Yeah. In theorem 9.16, the parametric equations of a line L through the point P sub O with direction numbers A, B, C are given by x equals to x sub O plus AP. So, dinagdag lang si A. Kasi yan yung direction numbers. Si Y naman equals to Y sub O plus BP. And then Z equals to Z sub O plus CP. Ito yung parametric equation of a line through the point P sub O with the given direction numbers. So, for example, find the parametric equations of the line L through the point with direction numbers. Pag sa given ninyo class na example, pinapahanap yung parametric equation and then may given na direction numbers, ang gagamitin ninyo na formula is sa theorem 9.16. Kung ang pinapahanap lang is parametric equation, but hindi given yung direction numbers, ibig sabihin theorem 9.13 yung gagamitin ninyo. what is the relation of L to the coordinate planes? So, substituting in this equation class, we have x is equal to x sub o. Ang x sub o natin dito is 3. And then, ang a natin is 4. Okay, set of direction numbers natin is A, B, and ang B natin is 0. And then C is negative 2. A is 4, B is 0, negative 2 is our C. Those are the direction numbers. Okay, so kung y is equal to y sub o plus bt, ang y sub o natin is negative 2, diba? And then, b, ang b natin is 0, so 0 times t is 0, so that's why ang y natin is y equals to negative 2 lang. And then, z naman, substitute natin dito, ang z sub o natin is 5, so eto siya. And then, ang c natin is negative 2. So, negative 2 times t. So, z equals to 5 minus 2t. Okay, so, these are the parametric equations of the line L through the point with the given direction number. Since all points on the line must satisfy all three of the above equations, L must lie in the plane y equals to negative 2. This plane is parallel to xz plane. Okay, yung na-discuss doon sa first na module. Kung y is equal to k, ibig sabihin parallel siya sa xz plane. Kung z is equal to k, parallel siya sa xy plane. Kung x is equal to k, parallel siya sa yz plane. So therefore, ang L natin dito class is parallel to xz plane. So parallel siya kay xz. If none of the direction numbers is 0, the parameter t may be eliminated from the system of equations 2. So we may write, kung walang 0 sa direction numbers natin, if possible ba? Kasi hindi always na may 0. So, ibig sabihin nun yung ma-open na parametric equations is lahat may variable t. So, para na-eliminate yung isa sa mga parameter t, we may write x sub o x minus x sub o over a equals to y minus y sub o over b equals to z minus z sub o over c. So, solving for the value of t sa tatlong equation na to. So, equate lang natin silang tatlo. If walang 0 sa direction numbers. For the equations of a line, so for any value of t in equation 2, the ratios in equation 3 are equal. So conversely, if the ratios in equation 3 are all equal, we may set the common value equal to t and the equation 2 is satisfied. So if one of the direction numbers is 0, the form 3 may still be used if the 0 in the denominator is interpreted properly. So the equations x minus x sub o over a equals to y minus y sub o over b equals to z minus z sub o over 0. So let's say 0 yung isa sa mga denominator natin. A not equals to 0, b not equals to 0 are understood to stand for the equation. So sila lang yung equal, and si z minus z sub over 0 is z equals to z sub o. So the 2-point form for the equation of a line also may be written symmetrically. So the equations is are called the symmetric form for the equations of a line. So ang tawag dito class is symmetric form for the equations of a line. So dito sa Analytic Geometry and Trigonometry class, marami kayong ipapamiliarize na formulas. For example, find the point of intersection of the line L equals to the ordered pair the ordered triple rather x, y, z such that x equals to 3 minus t. Okay, so ito yung given natin. Y equals to 2 plus 3t and z equals to negative 1 plus 2t. So ang hanapin natin dito is the point of intersection of the line with the plane S equals to the triple ordered pair xyz such that z equals to 5. So, hanapin natin yung point of intersection ng line na to at saka yung plane. So, denoting by point P X sub O, Y sub O, Z sub O, the point of intersection of L and S. So we see that Z sub O must have the value 5. Okay, kasi given naman yung plane natin na Z is equal to 5. So, ibig sabihin nun, ang Z sub O natin dito is equal to 5. So, from the equation Z equals to negative 1 plus 2t, we conclude that at the point of intersection, so pwedeng eto, since may value na tayo ng Z, substitute lang natin dito sa isa sa mga equations natin, parametric equation. So, we replace Z by 5. So, magiging 5 equals to negative 1 plus 2t. So, eto siya. Okay, galing siya dito class. Eto class is galing dito sa equation na yan. Okay, or solving for t, we have t equals to 3. So, then, yung x sub o natin equals to 3 minus, replace t by 3 kasi yung na-obtain natin na t is 3. So, 3 minus 3 is 0. So, ang x sub o natin is 0. Same with the y sub o. So, we have 2 plus 3 times 3 is 11. So, we can conclude that p, or the point p, is equal to the line L intersect with the plane S, has coordinates 0, 11, and 5. Sa 0, yan yung na-solve natin dito. Sa 11, yan yung na-solve natin dito. And then si 5 is yan yung value ng Z. Okay. Ang intersection nila, point of intersection nila is 0, 11, and 5. So, madali lang. Kasi formula lang and then substitution. But, nakakalito yung pag-analyze. In this next example, find the equation of the line through the point P and parallel to the line through the points Q and R. So, hanapin natin yung equation ng line through this point, and parallel yung line na yun, yung point na yun is parallel to the line and parallel to the line through the points Q and R. So, the line through Q and R has direction numbers. Okay, so kunin natin yung direction numbers ni line ni points ng Q and R. So, ang direction numbers niya is negative 2 minus 1 is negative 3. Negative 1 minus 4 is negative 5. And then 5 minus negative 6 is positive 11. So, ang direction numbers ni point Q and R, set of direction numbers niya is 3, negative 5, and 11. Therefore, using the formula 2, the parallel line P is given by the equation. So, using the formula 2, x is equal to 2. Ang x sub o natin dito is ito. Okay, this is our x sub o, si 2. Y sub o si negative 1. And then, z sub o si 3. Okay. So, x is equal to 2, that is x sub o minus 3 times t. Si 3, galing yan kay yung direction numbers na na-solve natin sa Q and R. And then, si y naman, kaya diba yung sa theorem 9.16 ba yun? X is equal to x sub o. Okay, ito yung formula doon sa theorem 9.13 ba? Minus, plus AT, where A is the direction numbers. Okay, so substitution lang. Si 2, galing dito sa point natin. And then, minus 3, kasi yung 3 is yan yung direction number. Isa sa direction number ng points na Q and R. Tapos, y naman, y sub o is negative 1 minus 5 kasi yung isa sa next or pangalawang direction number is negative 5 times, and then t, so negative 5t, and then z is 3, z sub o is 3 plus 11 yung pangatlong direction numbers times t. So formula lang talaga yung kailangan natin dito sa analytic geometry in 3 dimensions. Any 3 points not on a straight line determine a plane. While this characterization of a plane is quite simple, it is not convenient for beginning the study of planes. Instead, we use the fact that there is exactly one plane which passes through a given point and perpendicular to a given line. So we let P sub O, X sub O, Y sub O, Z sub O be a given point, and suppose that a given line L goes through the point P sub 1 and has direction numbers A, B, and C. So in this theorem, the equation of the plane, okay, ito yung formula na naman. The equation of the plane passing through point P sub O and perpendicular to L. Tandaan ha, equation of plane passing through point P sub O and perpendicular to L is A times X minus X sub O plus B times Y minus Y sub O plus C times Z minus Z sub O equals to 0, where si A, B, and C dito are the direction numbers. So take note that only the direction of L and nor the coordinates of P enters the above equation. So we obtain the same plane and the same equation if any line parallel to L is used instead. Okay. For example, class, find the equation of the plane through the point P sub O, which is perpendicular to the line through the points P sub 1 and P sub 2. So using the formula, the theorem 9.20, okay, equation yung hinahanap dito, equation of the plane. Okay, so the line through the point P sub 1 and P sub 2 has direction numbers. Ibig sabihin, ito kukunan natin doon ng direction numbers kasi kailangan man natin doon sa formula natin sa theorem 9.20. So ang direction numbers niya class is negative 11, negative 3, and 4. Bakit siya naging negative 11? Kasi negative 6 minus 5 is negative 11, negative 1 minus 4 is negative 3, and then 1 minus 4 is negative 3, and then 7 minus 3 is positive 4. So the equation of the plane is, okay, etong negative 11 na yan, di ba yan na yung direction numbers? So we let this one as our A, okay, and then si negative 3 naman as our B, and then si 4 naman as our C. Okay, so substitute lang natin sa equation of the plane sa theorem 9.20. So replace A by negative 11. Si X is X pa rin yan. And negative 5 na yan, galing yan dito sa point P sub O, minus si 3, galing yan dito kay B. And then si Y is constant, minus yung 2 na yan is galing dito. And then plus 4, yung 4 is yan yung direction numbers natin. Direction, isa sa mga direction number. And then Z plus si 3 is galing siya dito. Kaya siya naging positive kasi diba Z minus Z sub O. So ibig sabihin Z minus the negative 3 is magiging positive 3 equals to 0, or kung i-simplify natin yan, we get this equation 11x plus 3y minus 4z minus 73 equals to 0. So all lines perpendicular to the same plane are parallel and therefore have proportional direction numbers. In definition 9.22 class, a set of attitude numbers of a plane is any set of direction numbers of a line perpendicular to the plane. Okay, so dito naman, may tinatawag tayo na set of attitude numbers. Yung set of attitude numbers na yan, class, is any set of direction numbers. Okay, attitude numbers is any set of direction numbers of a line perpendicular to the plane. So, in example, above, etong sa 9.21, 11, 3, and negative 4 form a set of attitude numbers of the plane. Okay. So, bakit? Kasi diba, ito yung na-obtain natin na equation. Equation of the plane. Kasi ang sabi man niya dito, a set of attitude numbers of a plane. So, ito yung equation ng plane is any set of direction numbers of a line perpendicular to the plane. So, 11, 3, hago negative 4 na ginan is set of attitude numbers of the plane. Si set of direction numbers kasi na was kanyan sa kapag minus si ko duwati man nakakuha si ko points up minus so duwati man na point o duwati man na coordinates o duwati man na point. Si attitude numbers na sinyo kilay si ko equation o plane. Basta kung tunay pado numerical coefficient na pado x na gito na isaw to ko mga attitude numbers. Sumambos na numerical coefficient na pado y na isaw to ko mga set of attitude numbers. Ito yung bida ni Rano. Si set of direction numbers na kausaron sa formula x sub 2 minus x sub 1. Okay. So, saan sa makuha yung result na gito direction numbers na after to na miya kuha mini substitute yung si equation of the plane sa theorem 9.20 nasad din sa final result yan nasad din sa mga numerical coefficient pwede mga variables sa x, y, o z na gito a set of attitude numbers. For example, class, what are sets of attitude numbers for planes parallel to the coordinate planes? So, a plane parallel to the YZ plane, okay, has an equation of the form x minus c equals to 0. Diba? Kung YZ plane, ibig sabihin nun na ayan ang value niya na x, where c is a constant. A set of attitude numbers for this plane is 1, 0, 0. Si x na value niya, si y, si z na 0, 0. So that's why sa YZ plane na, yung set of attitude numbers yan na 1, 0, 0. A plane parallel to xz naman, ayan na value niya si a na si y, na ayan 0 sa yan na si x ago si z. So ayan, set of attitude numbers yan na 0, 1, ago 0. Si y boy na value niya. Let's say, ayan si tanong sa yan na 1. And any plane parallel to xy plane has attitude numbers 0, 0, 1. Kasi xy plane man, so ay 0, 0 saya si x sabi si y na na-value niya si i na si z. Since lines perpendicular to the same plane or parallel planes are themselves parallel, we get at once the next theorem. In theorem 9.24 class, two planes are parallel if and only if their attitude numbers are proportional. Okay? So, parallel yung dalawang planes if and only if yung attitude numbers nila are proportional. In theorem 9.23, if A, B, and C are not all zero, the graph of an equation of the form ax plus by plus cz plus equals to 0 is a plane. Kung if A, B, C are not all zero. Ito yung magiging equation niya. Ang tawag dito is a plane. For example, class, find an equation of the plane passing through the points. Okay, ito yung given natin na points, tatlo. So, hanapin natin dito is equation of a plane. Okay. So, since the 3 points lie in the plane, each of them satisfies equation 1. So, we have si 2, 1, 3 na we have 2a plus b plus 3c plus d equals 1. Okay, si 1, 3, 2 muna, i-substitute si root. Okay, a, diba x, y, z, ayan. Yung sabi so formula si theorem 9.20 for ax plus by plus cz plus d equals to 0. So, i-substitute yung bugi mga points. Okay, sa mga muna, negative 1 times a is negative a, 2 times a is 2 times b is 2b, 4 times c is 4c plus d. So, solving for a, b, c in terms of d, we obtain, ito yung ma-obtain natin, solving for a, b, c in terms of d ha. So, we can now choose any value for d. So, it is convenient to take d equals to negative 25. So, we get the equation. Kung ang d natin is negative 25, ang magiging a natin is 3, ang b natin is 4, and then c natin is magiging 5. So, we get the equation 3x plus 4y plus 5z minus 25. Okay. So, si 3, yan yung na-obtain natin na result kay A. Si 4 naman is kay B. If ang D natin is negative 25. Tapos, si 5, yan yung sa C. And then, minus 25. That is our D, which is equal to 0. So, this is an equation of the plane passing passing through the points. Itong tatlong points na to. So, the next topic in this module is the angles distance from a point to a plane. Okay, from a point to a plane na tayo. We recall that if line L sub 1 has direction cosines, lambda sub 1, mu sub 1, and mu sub 1, and the line L sub 2 has direction cosines, lambda sub 2, mu sub 2, and mu sub 2, then the cosine theta is equal to this, where theta is the angle between L sub 1 and L sub 2. In definition 9.25 plus, let P sub 1 and P sub 2 be two planes, and let L sub 1 and L sub 2 be two lines which are perpendicular to P sub 1 and P sub 2 respectively. Then the angle between P sub 1 and P sub 2 is by definition the angle between L sub 1 and L sub 2. Furthermore, we make the convention that we always select the acute angle between these lines as the angle between P sub 1 and P sub 2. So, ito yung sa figure 2. If this is our L sub 2 and this one is our L sub 1 naman, then ito yung plane natin na P sub 1, ito yung plane natin na P sub 2. So, si L sub 1 is perpendicular siya kay plane P sub 1. Si L sub 2 naman is perpendicular siya kay plane P sub 2. The angle theta between the planes A sub 1x, B sub 1y, and C sub 1z plus D sub 1 equals to 0, and A sub 2x plus B sub 2y plus C sub 2z plus D sub 2 equals to 0 is given by this formula. Okay, so ito yung angle theta between the planes. Cosine theta equals the absolute value of the A sub 2 times A sub 1 times A sub 2 plus B sub 1 times B sub 2 plus C sub 1 times C sub 2 over the square root of A sub 1 squared plus C sub 1 squared plus C sub 1 squared multiplied with the square root of A sub 2 squared plus B sub 2 squared plus C sub 2 squared. So, in the following corollary, two planes with attitude numbers, okay, ating mga attitude numbers natin are perpendicular if and only if, okay, perpendicular siya if A sub 1, A sub 2 plus B sub 1, B sub 2 plus C sub 1, C sub 2 equals to 0. For example, find the cosine theta, where theta is the angle between the planes. Kung plane, ito yung cosine theta natin. So, 3x minus 2y plus z equals 4, and x plus 4y minus 3z minus 2 equals 0. So, substituting in the formula 9.26. So, substitute lang natin dito, class. Ang A natin dito is si 3. A sub 1 rather is yung first plane natin. This is our A sub 1. It follows also that this is our B sub 1. And then C sub 1. And then yung pangalawang plane naman, we have A sub 2 here. That is equal to 1 ha, pag walang nakalagay na numerical coefficient. Si 4 is our B sub 2. And then si negative 3 is our C sub. Siya yung C sub 2 natin, B sub 2, tapos A sub 2. So, gamitin lang natin yung formula as theorem 9.26. So, ang A sub 1 natin is 3 times 1, ang A sub 2, plus yung negative 2 natin is B sub 1 times B sub 2 na 4, plus P sub 1 na 1, okay, kasi walang nakalagay yung numerical coefficient, times C sub 2 na negative 3. Then sa denominator din, substitute lang din natin si 3 squared plus negative 2 quantity squared plus 1 quantity squared. Tapos, pangalawa is 1 squared plus 4 squared plus negative 3 quantity squared. So, this is equal to, cosine theta is equal to 4 over the square root of 91. So, this is the cosine theta, where theta is the angle between the planes. Okay, ito yung mga plane, ito yung planes na given. So, formula lang din, class. Two non-parallel planes intersect in a line. So, every point on the line satisfies the equation of planes, and conversely, every point which satisfies the equations of both planes must be on the line. So, therefore, we may characterize any line in space by finding two planes which contain it. Since every line has an unlimited number of planes which pass through it, and since any two of them are sufficient to determine the line uniquely, we see that there is an unlimited number of ways of writing the equations of the line. So the next example shows how to transform one representation into another. So in example 9.29, the two planes 2x plus 3y minus 4z minus 6 equals 0 and 3x minus y plus 2z plus 4 equals 0 intersect in the line. That is, the points which satisfy both equations constitute the line. So, find a set of parametric equations of the line of intersection. So, hanapin natin dito is set of parametric equations. So, we solve simultaneously the above equations for x and y in terms of z. Okay, so solve natin yung equation natin simultaneously in terms of x, for x and y in terms of z. Kung dito, so x, so magiging 2 over 11. So, solve natin to simultaneously, class. So, using the equation, second equation class ng plane, we can solve y in terms of x and z. So, and after that, yung value ni y dito, class, is magiging 3x plus 2z plus 4, di ba? And then, i-substitute natin dito sa pangalawang term. So, magiging 2x plus 3 times 3x plus 2z plus 4. Galing dito. Minus 4z minus 6 equals to 0. And then after that, pwede natin ma-solve si x in terms of z. Okay. Then we express z in terms of x and express z in terms of y. To get the symmetric form for the equations of the line, x plus 6 over 11 divided by negative 2 over 11 is i-equate lang natin siya. So, setting z is equal to t, you can also write. Okay, so kung i-set natin si z as t, so magiging x is equal to negative 6 over 11 minus 2 over 11 times t. Y is equal to 26 over 11 plus 16 over 11 times t. And z equals to t. Which are the desired parametric equations? Three planes may be parallel, may pass through a common line, may have no common points, or may have a unique point of intersection. So if they have a unique point of intersection, class, the intersection may be found by solving simultaneously the three equations of the planes. If they have no common point naman, an attempt to solve simultaneously will fail. A further examination will show whether or not two or more of the planes are parallel. Another example is example 9.30 classes. Determine whether or not the planes P sub 1, okay, and P sub 2, P sub 3, intersect. So, tingnan natin if itong dating planes na to is mag-intersect ba sila. If so, find the point of intersection. So, eliminating z between p sub 1 and p sub 2, we have, kung eliminate natin dito si z, using the elimination, okay, so ang ma-obtain natin na equation is 4x plus y minus 1. Algebra lang po. And then, eliminating z between p sub 2 and p sub 3 naman, we find 3x plus 4y minus 3 equals to 0. So, we solve equations 1 and 2 simultaneously. Okay, so solve natin to simultaneously. We get x is equal to 1 over 13 and y equals to 9 over 13. So, I want you to solve this one para ma-verify ninyo if tama ba na x natin is equal to 13 and y natin is equal to 9 over 13. So, substituting in the equation for phi sub 1, we obtain z is equal to 32 over 13. So, therefore, the single point of intersection of the three planes is 1 over 13, galing siya dito. And then 9 over 13 si y. And then z naman is 32 over 13. In example 9.33, find the point of intersection of the plane 3x minus y plus 2z minus 3 equals to 0, and the line x plus 1 over 3 equals to y plus 1 over 2 equals to z minus 1 over negative 2. So, before that class, before natin hanapin yung point of intersection ng plane at saka line, we need to write first the equation of the line in parametric form. So, ang parametric form is x equals to x sub o. Yan yung point, di ba? And then plus, this is x sub o, plus a, where a is a direction number, times the variable t. So, tingnan lang natin dito lahat ng nasa denominator ng equation na to. Yung 3 na yan, yung 2, yung negative 2, those are the direction numbers. Sa x, ang direction number natin dito, a equals to 3. Sa y naman, ang direction number natin dito, b equals to 2. And z is c equals to negative 2 yung direction number natin. So, substitute lang natin. So, we have x is equal to negative 1 plus 3 because yung 1 na yan, yan yung point na eto. So, transpose natin yan, magiging negative. So, that's why naging negative 1 plus yung a natin, replace it by 3. So, the same also with y equals to negative 1 plus 2t. So, since positive 1 yan, transpose, magiging negative 1. And then, yung 2 na yan, dito natin ilalagay sa tapat ni t. And then, the same with z minus 1 over negative 2. Since negative yan, transpose, magiging positive. Tapos, ang direction number natin dito is negative 2. The point of intersection is given by a value of t. So, let t equals to t sub o. So, this point, satisfy the equation of the plane. So, ito yung equation ng plane natin. So, i-replace lang natin si x by this one. And then, si y naman, replace it by negative 1 plus 2t. And then, si z, replace it by 1 minus 2t. So, class, may minus 3 po dito. Typo error. Okay. So, we have 3 times negative 1 plus 3t sub o minus the negative 1 plus 2t sub o plus 2 times 1 minus 2t sub o minus 3 equals to 0. At t sub o equals to 1, the desired point is 2, 1, and negative 1. 2 because if we substitute t sub o here equals to 1, so magiging negative 1 plus 3 times 1 is magiging positive 2. So, diba, yung ito yung x. And then, ito naman is ito yung pinalitan natin ng variable y. And then, this one is our z. So, the same with the x, y, and z. Ang desired point natin is 2, 1, negative 1, at t sub o equals to 1. In theorem 9.32, the distance d from the point p sub 1 to the plane ax plus by plus cz plus d equals to 0 is given by this formula. So, tandaan nyo itong formula na to. Ito yung distance from the point P to the plane. Okay, so let's give an example. find the distance from the point to negative 1 and 5 to the plane 2x plus 2y minus 2z minus 7 equals to 0. So, substitution lang class sa formula. Ang A natin dito is si 3, and then ang B natin is si 2, and then ang C is negative 2, and then D is negative 7. Tapos ang X natin dito is si 2, and then Y is negative 1, and then 5 is the Z. So, we obtain D is equal to 13 over the square root of 17. The last topic in this module is the cylinders. In order to sketch the graph of a surface, it is useful to determine the curves of intersection of the surface with planes parallel to the coordinate planes. These curves are called traces. Okay. So, ang tawag doon sa mga curves na yun are traces or cross sections of the surface. A cylinder is a surface that consists of all lines called rulings that are parallel to a given line and pass through a given plane curve. For example, sketch the graph of the surface z equals to x squared. Notice that the equation of the graph z equals to x squared doesn't involve y. This means that any vertical plane with equation y equals to k is parallel to the xz plane, intersects the graph in a curve with equation z equals to x squared. So these vertical traces are parabolas. So in figure 3 shows how the graph is formed by taking the parabola z equals to x squared in the xz plane and moving it in the direction of the y-axis. The graph is a surface called a parabolic cylinder, so made up of infinitely many shifted copies of the same parabola. So here, the rulings of the cylinder are parallel to the y-axis. So ito yung graph niya, class. Ang graph ng z is equal to x squared since it doesn't involve y, diba? So, ibig sabihin nun, kung ano yung wala dito sa given natin na graph, a surface, kung ano yung variable na wala dito, ibig sabihin doon siya, yung rulings natin is parallel siya doon sa variable na yon. So, since dito ang surface natin is z equals to x squared, walang y, ibig sabihin ang rulings niya is parallel sa y-axis. So, ito yung rulings na sinasabi natin. Ito yung rulings or the generator. Okay. So, it is a parabolic cylinder. Okay, a parabolic cylinder in the xz plane. So, dito lang siya sa x and z plane. Kasi ang involved lang mo ng variable is x and z. We notice that the variable y is missing from the equation of the cylinder in example 9.34. This is typical of a surface whose rulings are parallel to one of the coordinate axes. If one of the variables x, y, or z is missing from the equation of a surface, then the surface is a cylinder. Another example, identify and sketch the surfaces of x squared plus y squared equals 1. And then sa letter B is y squared plus z squared equals to 1. So sa first example class is since z is missing here, kasi ang involved lang na variables surface natin is x and y. And the equations x squared plus y squared equals to 1, where z is equal to k, represent a circle. So it represents a circle with radius 1, right? In the plane z equals to k. So the surface x squared plus y squared equals to 1 is a circular cylinder whose axis is the z-axis. So here are the rulings. Here the rulings are vertical lines. So since ang wala dito is CC, ibig sabihin yung generator natin or rulings natin dito is parallel siya kay z-axis. Okay, di ba? Ito yung rulings natin. Yan, yung mga lines na yan, which is parallel sa z-axis. Okay, kasi siya yung wala sa na variable sa given natin na surface. So, ito, this is consists of circles with the radius 1. So, maraming circles yan, pinagdikit-dikit. So, ang nabuo is a circular cylinder. In this case naman, sa letter B na examples, in this case, x is missing and the surface is a circular cylinder whose axis is the x-axis. Okay. So, in this figure class, sa figure 5, di ba ang given natin na surface is y squared plus z squared is equal to 1. It is obtained by taking the circle pa rin siya. Y squared plus z squared equals to 1. Where x is equal to 0 in the yz plane. Okay. So, and moving it parallel to the x-axis, since yung given natin na surface, ang missing na variable is x, which means ang rulings ng graph natin class is parallel siya dito sa x-axis. So, kung mapapansin ninyo, yan yung mga rulings natin. This is a formula of a circle. Etong nabuo na circular cylinder, lahat yan mga circles. Na ang formula is y squared plus z squared equals to 1. And then, ang axis niya is the x-axis. Ibig sabihin, dito siya mag-revolve kay x-axis. So, when you are dealing with surfaces, it is important to recognize that an equation like x squared plus y squared equals 1 represents a cylinder and not a circle. The trace of the cylinder x squared plus y squared equals 1 in the xy plane is the circle with equations x squared plus y squared equals 1 and z equals to 0. So, yun yung traces niya. Trace ng cylinder natin na x squared plus y squared equals to 1 rather.